Go. Thank you.
All right, thank you very much for this introduction. Actually, I think you covered it pretty well. I don't think I need to add anything on top of that. Hello, everyone. Welcome to my talk about 10 machine learning concepts every startup founder must know. So this is when I usually talk a little bit about me, but again, Dilara already took care of that. So yes, I'm an AI and machine learning consultant. I work with data, cybersecurity, everything that she mentioned. We can skip that part. I'm really not that interesting. And since we're talking today about 10 machine learning concepts every startup founder must know, let's talk about why. Why does every startup founder need to know those concepts? And the thing is that, as probably all of you know, if you're here, is that data science and machine learning are really becoming more and more prominent in today's tech industry. And even if you're not a data scientist, you've probably encountered machine learning and data science quite a lot. And that's especially true for startup founders, where even if your product does not have something, it's not based on machine learning is all around you. Though there are terms that you should probably know when you talk to investors, to potential clients, even with your own team. You can't really avoid machine learning anymore, and you shouldn't want to. So why not harness it and make sure you know all the right things that can help you make your startup even greater. So we'll cover 10 concepts that are very basic in machine learning, which doesn't mean that they're simple. Some of them can be very complex, but I tried to build a lecture so it would be easy to understand, and I hope it works. So let's start with the basics. Machine learning model. That's the one thing that everyone is talking about, right? So the definition of a machine learning model, as you can see here, is a mathematical model that uses sample data in order to make predictions or decisions without being explicitly told how to solve that task. So that's simple enough, right? We can move forward. Yeah. No, I'm joking, of course. Wait, I lost my presentation. Yes, let's take it with an example. So let's take the example of a startup founder that started off as a piano teacher. She teaches piano, and she doesn't just teach regular piano classes. She teaches piano classes to cats, and she teaches cats how to play Beethoven on the piano. It's a very specific niche, I know. And she decided she's really, really good at figuring out which cats can or can't or won't be able to learn how to play Beethoven on the piano, and she wants to make a startup out of it. So I would give the example of a friend of mine who's a piano teacher, and more specifically, she teaches cats how to play the piano, how to play Beethoven on the piano. And she wants to create a startup that can predict whether a cat would be able or not to learn how to play Beethoven on the piano. So in that case, that's the machine learning model that she needs. She needs a model where she can input the data about the cat and get the output of predictions whether the cat can or can't learn how to play the piano. So I'm just going to go over the terms again. That the input that the model gets, the model, which is a program, it's code. It gets the input of data, and then the output is predictions about the cat. And the part about the machine learning is because the model is never told how to do that. The model is it learns by itself what the patterns are. Basically, by the fact that I give it, at the first stage, I get the data. And we'll go more over that later. But I never tell the model, okay, all white cats are really fast learners, and black cats prefer Bach. I don't do that. I just give it the data, and the model learns by itself. And that's the machine learning part of the machine learning model. Because the model is a machine, and it learns. So that was our first must-know concept. Now another one, examples or samples. Now I have to apologize here because as data scientists, we're kind of mean, and we like to just take terms and words that already have a certain meaning and then use them for something different. So when we say examples here, we're talking about data points. More specifically, the data points used for training the model or for prediction. So for example, with our kitten model, each cat, each kitten is an example or a sample. And in our case, we can see, for example, if we have Mr. Teeny, Fluffy, and Snowball here, each of those would be a sample. Then we have the third concept, which would be features. And again, here I have to apologize that when we talk about features in the context of machine learning, we are talking about representations of the data we have for each sample. We do not mean the same thing as software engineers mean when they say features. I do apologize for that. So with our kitten model, some feature that I'll have, or maybe before that, I'll also mention that notice, well, if you are a startup founder or a future startup founder, that's a mix-up that could happen when you're talking to your software engineers or to your data scientists, and they're saying features. Make sure you realize that those could be very different things. So don't mix those two up. So again, in our example, a feature could be, for example, if the kitten can play the guitar, because maybe if they play guitar, then they already have knack for learning instruments. Or maybe if they like weird hats, that could be a feature that maybe helps understand if this cat would be able to learn piano. I don't know. Okay. So here is what we would call a data set. It's just an example, not in the sense that I said earlier. You confuse ourselves as well with all those words that are used for different meanings. So we can see how a toy data set for such a model might look. So as you can see, there is a row for each example, for each data point, for Fluffy, Mitzi, and Princess Carolyn. And then we have the features. Age in months, likes hats, plays guitar in color, and each of the data set, each of the data points, we have the value for that kitten, for that example, for that kitten. I have the value for each feature. So for example, if I'm looking at Fluffy, then I know that Fluffy is 4 months old, and that Fluffy likes hat and doesn't play the guitar, and Fluffy's color is black. So that's what a data set would look like. At least when we're talking about tabular data that comes in tables, but that's really beyond our scope here, so I won't go into it. Just keep in mind that there are different forms of data, and we're talking about tabular data here. So let's talk about labels. Labels are another concept. And the label is the piece of information that we want the model to predict. So let's see if you've been listening. Here is the first interactive part of our talk. With our kitten model, what would the label be? And here, if you could write in the chat, that would be great, what your answer is. Again, the question is, for our kitten model, what would the label be? Okay, I'm not sure I can see your comments, so I'll just go ahead and say that the label would be whether the kitten would or wouldn't be able to learn the piano. And that, because that's what we want the model to predict. Again, the startup here is a product that would be able to predict whether each kitten would or wouldn't be able to play the piano, to learn how to play the piano. And if we're looking at the data set, then the data set would also have the label. The data set we have when we're training the model, which again we'll go into soon, would have the label for each example. So Fluffy was able to learn, and Mitzi was able to learn, and Princess Caroline wasn't. Okay, so I talked about a lot about learning and training, and let's see what that actually means. So as I mentioned earlier, the model it needs to first go over some data to learn, and only then it can make predictions regarding new data. So if you're building your startup and you want to have your model, you can just start with nothing. You need to have data and also tag data. By tag, they mean data that has labels, like I showed earlier, in order to build it. And that's the stage where it gets data for the first time, the model, and it uses it to learn. That's called the model training. The data that's used for this purpose, is called a training set. So for the training stage, I'll take my blank model and I'll feed it a lot of kittens. So for instance, if I'm the data scientist working with the startup founder / piano teacher on this specific venture, I'll tell her, okay, you've trained cats before, you have the data. Please give me the data of cats that you taught before and whether they were or weren't able to learn how to play the piano. And then she's like, okay, here's all my data. And I'll say, no, I don't need all of it. Please keep a part of it, like maybe 20% of it. Only give me 80%. And she'd be confused, but she do that because, I'm the expert. That's how it goes. And then I'll use that to train the model. I'll give all of that data to the model as input, together with the labels. And then the model learns by itself the patterns, and it learns how to predict exactly which kittens would or wouldn't be able to play. Then I have a trained model, and then I move on to the testing phase. Because the testing is where I have a model that it claims that it knows stuff, but I need to test, to be able to test and see whether it knows what it's doing, whether it's good, whether its predictions are accurate. So during the testing phase, what I'll do is I go back to my friend / piano teacher for kittens / startup founder, and I'll say, okay, you remember those 20% that I asked you to hold out? Can I please have them now? And she's like, okay, that's really weird. You could have gotten them earlier, but here. And I'll take that data and I'll give it to the model. And I'll ask it to predict whether or not that those kittens would, because we already know the answer, but I wouldn't give it the answer, would be able to learn to play the piano. And the model, seeing only the data without the labels, without the answer, would make its predictions. And then I could take that and compare it with the real answers. Those are, we call that sometimes ground truth. My ground truth about whether the cats actually were able to play the piano. And that way I can know how good my model is. I can test and see if it's accurate, or if it's really bad, or maybe it's better in certain sections and it does worse in others. There are different metrics, performance metrics, to see, to test how well the model is doing. We won't go into that here, it's out of scope, but just keeping in mind. So a quick recap, and then I'll also take some questions. We went over 5 concepts so far. We talked about a machine learning model and what it is. It's a model where you give it data and it learns the patterns by itself, and then it's able to make predictions. We talked about examples or samples being each data point. We talked about the features being representations of the data we have about each example. For example, for example. In our case, the examples would be kittens, cats, and the features would be for, maybe how old they are, or whether they can play another musical instrument. Then we have the label. The label is what we want the model to be able to predict. So in our case, it would be whether the cat can or can't learn how to play the piano. And then we have the training phase where we take a blank model, we give it the data together with the labels, and we have it learn. And the testing phase where we give the data, give the model data without the labels, and we see how well it's able to guess the labels, to predict them. So if you guys and gals have any questions for now that are specifically about what we talked about, there will also be time at the end of the talk for more abstract questions about life, the universe, and everything. But for now, if there's anything that wasn't clear or anything that is specific to those concepts, I would love to hear it, and I could answer them.
Yeah, guys, come on. I can't see any of your comments so far. Please don't hesitate.
Oh, okay, I thought maybe it's only me that's looking in the wrong place.
No, I will tell you once we have like something to share.
Okay, I see one comment here. Jane is asking how far in the future can ML predict? So that's a great question, and the answer is a bit complex. I'll try to answer shortly with something that could make sense without a general context, and that is that a machine learning model would be able to predict into the future as much as the data it was trained on is still similar to the data in the real world. The reason that we need to retrain models when we have working models, for example, if we are talking about the kitten startup. So if I train it, I can train it on data from the last years, and I'll do a really good job, and I'll have a model that predicts beautifully about each kitten. But then the world could change. You know, kittens these days, all they do is watch YouTube all the time, and they don't practice like they should. So maybe in a few years, the data that I had that represented kittens in the past won't be similar enough to kittens today. And then my model wouldn't be able to predict as well because the model was only trained on past data, and the past data isn't a good representation of today's data anymore. Does that make sense? So again, the answer is that it's not something that's specific to the model. It's specific to how much the world changes and how much the data that the model is getting is different than what it used to get, or it presents different things than what it used to get. All right, I hope that answers the question. Yes, excellent. Great. Any more questions?
Can't see anything for now.
All right. We can move on.
I think the guys hesitate to ask questions.
So maybe I should say now that there's an interactive part coming up, and you all should participate. Otherwise, we'll be stuck here forever.
Oh.
Beware. Think of worse things. Beware. Yes. Okay. So let's talk about the next concept: supervised machine learning versus unsupervised machine learning. Basically, I'm sorry, I lied. Everything we talked about, I presented it as if it's true for machine learning in general, but that was actually supervised machine learning. Supervised machine learning is the most common form of machine learning, I would say, and that's what we call when we have a label. So in our case, where we wanted the model to predict something that was very specific and we knew about it in advance. We said, okay, I want to know whether each kitten can play the piano. And then I gave the model the supervised training set because I had the answer, and later I asked it to predict it. But then there's also another type of machine learning problems, which is unsupervised machine learning, and that's where we don't have specific labels. And some examples for unsupervised machine learning are anomaly detection or clustering. We'll go into that later. It's not as intuitive, so just keep it in mind, and we'll talk more about it in the rest of the talk. So if we're talking about supervised, we can talk about two main aspects. Basically, supervised machine learning would be either classification or regression. And the difference is whether the label is categorical or if it's numeric. Classification is when I take, my problem is having the model take each sample, each example, and classify it into one of a few specific groups, a few classes. And regression is when the label is numeric, and I want the model to tell me the value, to predict the value for that sample. So here's the interactive part that I warned you about. So buckle up. You can answer in the comment section. I promise it's easy and it will be over soon. So classification and regression, everyone's favorite game show. Let's take a few examples, a few cases, scenarios, and you can tell me whether that would be classification or regression. So first, let's take our piano playing kittens scenario. Would that be classification or regression? I am looking at the comment section. Okay, you guys are not participating, so I'll just answer, even though I think it's fun, so it's your loss. In that case, in our case, yes, excellent. Thank you, Marina and Jane. Exactly, that would be classification, because I'm taking each example, each kitten, and I classify it into either the group of can play the piano or can't play the piano. Yes, thank you everyone for just participating. And so that's goes in the classification file. And let's talk about a different scenario. Maybe we have, maybe the startup is not about predicting whether a cat can or can't play the piano, because the startup founder, the piano teacher, she's a real believer in kittens, and she thinks each kitten would be able to learn to play the piano if only given enough time. So maybe the question is, how long would it take each kitten to learn how to play the piano? So what would that be? Is that classification or regression? Okay, that would be regression. So in that case, yes, thank you for those of you who answered. That's when I asked the model to predict a label that's numeric, asked it to predict how long it would take, whether I'm talking hours or days. That's a numeric prediction, and for that I need regression. Then, so that goes in the regression file. Then another one, maybe the startup founder actually wants to know what the favorite, how long would be the favorite piece of music or that kitten. If that kitten's favorite Beethoven piece is the Ninth Symphony, and I actually have no idea how long it is, let's say 9 minutes, just for fun. So what would that be, classification or regression? Yes, exactly. That would be regression. Way to go. And last scenario, we want to predict what's the favorite composer of each kitten? Is it Beethoven, or maybe it's Mozart, or maybe it's Bach? I hear kittens are very fond of Bach. So what would that be? Yes, excellent. That would be classification. Thank you all for participating. Okay, so that was supervised machine learning. Now let's talk about unsupervised a bit more. And again, I'll say it's less intuitive, so it might be a little complicated to fully grasp, but that's okay. We'll only give a brief intro now because, again, the concept here, the point of this talk is for you to have the general view of things and the broad sense of what we're talking about. If you're a startup founder now, or if you're planning on being in the future, then you don't really need to know at this moment the exact mathematical algorithms of how making everything work. What you need to know is that you want to know these things exist and that you could use them if you'd like, and you could learn more about them. And if you're talking to an investor or a client and they mention anomaly detection, then you want to know what they're talking about. If you're data scientists in your team, talk about clustering as a possible solution for your problems. You want to know what they're talking about. So we'll give the general sense of things, and even if you don't understand every single aspect of it, that's fine. So let's start with clustering. Clustering is when I take the data and I don't have a specific label, as I mentioned, because it's unsupervised learning. So what I do is I ask the model to predict groups, not to predict, but to derive groups from the data. Ask the model to look at the data, and let's also look at an example. Yes, kittens again. I know you've waited for it. I just want to let you know that I did not create this picture. This picture exists on Google. The internet has everything. So I have the data, and I want to know what groups are in the data. And then I ask the model to figure that out. And the model looks at the data. It looks at the different features. It looks at the mathematical representations of the reality. And it uses different algorithms, it doesn't really matter which ones at the moment, to cluster the different data points, the different samples, into groups, where the groups are all made of examples that are more similar to each other. In our case, that would be kittens that are more similar to each other. Oh, thank you for the comment section compliments about the graphic. So if we'll talk about a real world use case for that. For example, if you're working, I mentioned that I worked at armies, and armies monitors computer networks and watchdog for threats. So, for example, if you're monitoring a computer network, and you have the different computers, and you want to figure out what the different profiles are within the computer. Maybe I expect, for example, different profession within the company that I'm monitoring to behave differently in their computer use. Maybe I expect, for example, managers to always be in Zoom meetings, and I prepare presentations and slides, and I expect data scientists to only sit and code all day and read things on Stack Overflow and etc. But I don't know exactly how they'll behave. I just know that they'll behave differently. But I don't have the answers of exactly how I would spot a data scientist, the data scientist's computer. So in that case, I can use clustering. I can use the data that they have unlabeled, and I can put it into the clustering algorithm, and I can get back the clusters of data points that are more similar to one another. Is that clear so far? If not, actually we'll stop for questions soon. But if you have a question, if there's something that you really don't understand, I don't want you to stop, because then we'll just carry on for more of the talk. So feel free to ask in the comment section, and I'll stop and answer when I have the time. So anomaly detection, again, that's another example for unsupervised machine learning. And that's when I do something different. Again, I look at the data that I have, the untagged data that doesn't have labels. And I want to find the odd ones out. I'm asking my model to tell me which are the weird kittens, which are the kittens that really don't fit the rest of the data, don't look like the rest of the data set. An example for that is, again, an example for use case is, so say that you're monitoring a computer network or a device network, and then you want to threat manage. You want to find those computers that might have been hacked. And you don't know exactly what to look for. You don't know what their behavior would be like. You know, it can be different every time, but you do know that it will probably be different than the rest of the computers. So that's what you'll do. You'll use anomaly detection in order to detect the anomalies, the outliers in your data. Those examples look very different than the rest of the data. So that's let's stop over a point that basically we talk about that, but I know it's something that people get confused about quite often. So let's just make sure that you have it clear, the difference between classification and clustering. Do you know what it is? Because it could be confusing, because we have both of those. What they do is they take the data and they split it into groups, right? But the difference is within the label, another way to look at it is the predefined groups. With classification, I have predefined groups. I know I have the label for each sample, and I know what groups I'm asking the model to classify examples into. With clustering, I really don't. I don't have a label, or maybe I don't have any idea what groups I'm looking for. I have a reason to believe that there are such groups in the data, and I want the model to find them for me. So a quick recap, and then we'll go for questions. So you can start writing them in the comment section. We talked about what a machine learning model is. It's a model, it's a piece of code basically, but it's a model that takes data and learns patterns from the data by itself. We talked about examples or samples being the data points. In our scenario, those are the kittens. We talk about features being representations of the data we have, of each data point. About labels being what we want the model to be able to predict, at least when it's supervised. We talked about training, the training phase, where we take a blank model and give it the data for the first time, together with the labels, and we have it train over them and learn the patterns. And then the testing phase, when we have a model that has already learned, and then we want to see how well it learned and how well it's able to predict. So we give it data without giving it the labels, and then compare the model's answers with the ground truth, the true labels. We talk about supervised machine learning, which is everything we mentioned so far, and then unsupervised machine learning, where we don't have labels. And we talked about classification, where it's supervised machine learning when we ask the model to classify samples into groups, versus regression, when we ask the model to predict a numerical value. Then we also have clustering, where the model takes the data and figures out what groups exist within it, and which sample is within which group. And then there's also anomaly detection. Again, unsupervised, where the model takes the data and spots the anomalies, the outliers, those data points that do not behave like the rest of the data. So let's start for questions. Again, this is basically more for the technical questions, because there's still we still have a bit more to cover, but go ahead and feel free to ask your questions.
Hey, there is a question from Jane. Is there a limit to the volume of information that machine learning is capable to process?
That is an excellent question. So the answer is both yes or no. No is the more theoretical answer, in the sense that hypothetically I could just feed my model with as much data as I would, and that would actually be great because as a general rule of thumb, the more data that I can give my model to train on, the better it will be able to predict, to figure out those patterns. It's the same as with humans, really. I mean, the more that I see of the world, the more that I understand it. The more that I see of a specific something, the more that I'm an expert of it. So that's the theoretical answer. But then the practical answer is that the limit is really the computational resources that I have, because training could be very computationally heavy. It depends on the algorithm. We won't go into that too much today, but that could really be why I'll have to limit and only give a part of the data I have to the model, because otherwise I could just like sit and wait for it to train for weeks and not get it back.
Got it. Thank you so much for your answer, Noah. We have a comment, not a question, but a comment that Evgenia is feeling bad for the cats who don't belong to the group.
I get you, Evgenia, but it's okay. There's your own caste, you know. They don't need to live by society's rules. So, yeah.
I have a question. Oh, sorry. We have a question, and then I have a question of my own. Here is a question from Darken Rao. Hey, Noah. Thank you for your speech. I have a general question. Is it possible to become an employed machine learning specialist if you have no degree and you're self-taught specialist?
So that's an excellent question, and I'll actually, yeah, would it be possible to ask you to save that for when we end the talk, because I think that would be a better time for the more general questions.
Okay, so general questions should be saved for the end.
I think it's better, yeah, just because we're still in the technical things here.
Okay, then I'll.
I mean, just like a specific one, if I could ask you to remind me so it won't be forgotten.
Yeah, sure. I will remind it about it and show it once again on the screen, and then I'll save my question for the end too.
Okay, all right, looking forward to it. So let's get back to our concepts. These are the promised 10 must-know concepts that every startup founder must know. But I actually have a bonus for you, another concept. Are you interested? No, that's, of course, I mean, obviously you can't answer no. I apologize. It's a gimmick. Let's get to it. So when I prepared this talk and I asked people that I know from the tech community that are not data scientists, not machine learning experts, asked them what their questions are. The one I heard way too many times is just a general confusion about what is the difference between AI, ML, and DL. I mean, there is artificial intelligence, machine learning, deep learning. What's the difference? Are they the same? Are they when is what? And just not really understanding where those things go. So I'd really like to help make that more clear. Basically, artificial intelligence, or AI, is a very, very broad term that can describe almost any algorithm that does something smart. It's not necessarily machine learning. The strict definition is intelligence demonstrated by machines, which is, again, very, very abstract and doesn't really mean a lot. In practice today, when people say AI, they mean the general field of that includes also machine learning and also other ways to make smart algorithms, make algorithms that can maybe make decisions, for example, about different things. For example, the first computer program to beat the world's best chess player, which was in the 90s, if I'm not mistaken, that's considered artificial intelligence, and it was not based on machine learning. One misconception about AI is just something you should be aware of. It does not mean robots that have feelings, even though that would be adorable. Then we have machine learning. This is what we talked about for the last, I don't know, 30, 40 minutes or so. So I really hope that you know it by now, because if not, then I did a very bad job. Then there's deep learning. Deep learning is a specific subclass of machine learning models that use neural networks algorithms with many inner layers. Neural networks algorithms is it's a specific group of machine learning algorithms that are based off the way the human brain works. And again, I won't go into this too much. It's a huge topic. We could talk about it all day, but that's not really the scope here. The idea is just for you to know that it exists. And it's especially important if you're, again, startup founder, or if you're planning on founding a startup someday in the future, because it's a really hot topic right now. Everybody's talking about deep learning. And deep learning models, they have some fantastic results. I mean, they get really incredible results. But the problem is that they are extremely computationally heavy, and they require huge amounts of data, and have significant limitations. For example, they don't have any explainability, if that means anything to you, and if not, just don't worry about it. So it's usually, even though everyone is talking about it, if you're planning on founding a startup, please do not start with deep learning unless you have a really good reason to. That's something that I see a lot of startup founders doing. They, like we talk, when they want to create their first POC, their first product, and they're very excited about deep learning, but usually that would not be the best thing to use for an early stage startup. So please keep that in mind. But if you're a huge company, or if you have a really good reason why you need specifically deep learning because you cannot achieve your goals in any other way, then deep learning is a fantastic technology. Most of the state-of-the-art models, the best achievements we have in machine learning today are by deep learning algorithms. And deep learning is a part of machine learning, as said, and as you can see in the graphics here. And a small joke that's way too true about it is this very familiar tweet that when you are fundraising, you're talking about artificial intelligence. When you're hiring, you call it machine learning. And then when you're implementing, it's linear regression, just because linear regression is a specific machine learning algorithm that's considered very basic, even though it can still get the job done. This is just about, I put this here because I think also it's a startup founder. So you need to keep in mind that a lot of the terms that people use, they use for marketing purposes. And you would also see AI mentioned everywhere, and probably also deep learning. And just keep in mind that it doesn't actually mean it's the best thing to put into your product in the technical aspect of it. Okay, you are now all data scientists. Okay, I'm joking, of course, you are not yet, but I hope that by now you have a good understanding of those must-know concepts, those basic concepts that are not at all basic. They can be quite complex, and that you have that general sense that you need in order to push forward within your startup, whether today or in the future. Those concepts might help you and be able to better converse with both your own team or other stakeholders about those concepts. And thank you for listening. We'll get to the questions soon. Thank you for listening, and you feel free to follow me if you're interested in more talks that I give. I also sometimes write technical blog posts about different aspects in data science. Yes, questions?
Noah, thank you so much for this amazing lecture. We do have some questions and thank yous in our comment section bar. I wanted to ask my general question. If you met a lot of startuppers who know something about, not just know something about machine learning and data science, but actually know the concepts you were talking about today.
Yeah, so it really depends on the type of startup because I meet mostly those that have something to do with machine learning because I'm a machine learning expert, so that's how they get to me. And they would usually have a pretty good sense of the basics. They could sometimes be confused about the more complex stuff, and of course, not necessarily know the more technical details. Um, and the more you go into those founders that have startups that don't really have machine learning in their product yet or at all, but I think it's yet because everyone has machine learning now at some stage or later, then they're probably not familiar with I mean, maybe they'll know what a model is, but they'll confuse it with algorithm, and maybe they won't be so sure about the specifics of everything.
Got it. Thank you.
Sure.
Yeah, and we have the general question. Darken Rao asked us if it's possible to become an employed machine learning specialist if you have no degree and you're self-taught.
Yeah, so as I said before, it's a really good question, and I really get asked that question quite a lot. In general, yes, but it would be harder. Also, I can answer mostly about the employment market in Israel because that's the one I know more closely. So a lot, just because today data science and machine learning have become fields that are so attractive, a lot of people want to go into them, then a lot of employers, a lot of companies find themselves needing to screen more applicants, and then they use different measures different criteria that might not be the best ones, in my own opinion, to measure how good of a machine learning researcher that person is. So one of those criterions would often be if you have a degree in the field. Um, I don't think that that's a good way to do it because today we don't really have like a machine learning degree yet, do we? I mean, the universities teach different degrees, and then you have, for example, I learned neuroscience and psychology, and my theoretical background is from there, and a lot of people don't even know that you learn about machine learning and statistics and data in those fields. And for example, when people study computer science, then other employers might think that that's perfect for machine learning, but they could have no idea about. They could not take one course of machine learning, and or maybe they did. Maybe they took a lot of courses, but the degrees themselves, I don't think have a lot to do with it. But people sometimes use it as a way to screen applicants. That was the more pessimistic part of my answer, and the optimistic would be that despite all that, I have seen a lot of people that don't have a degree or don't have a so-called relevant degree do manage to get in the field. It takes more work and it might be harder, especially when the employment market is more difficult in general. We actually have a panel about that later. Dilara might want to talk about that. So it's possible that it could be harder. I would recommend, if you're interested in that, I would recommend that you try to talk to people that work where you live, and try to understand what it would be like in your own local market.
Thank you, Noah. And also thank you for kindly mentioning our career panel, which will take place later today. And will be featuring our lecturers from the conference. And I have a question about like kind of a follow-up question. In Russia, we right now have like a very a lot of advertisement of machine learning and data science courses, and usually they say like, "Hey, it's not that hard. You can just learn how to code on Python and become a data science specialist and get a lot of money and so on." So we have a lot of ads like that in all kinds of sources, like on YouTube and so on. Do you have something like that in Israel also as well?
Yes, we do. We have tons of them. I think again, just because a lot. I mean, it's a relatively new. It's not a new profession, but it has a new buzz around it. So it's very hot right now, and people are trying to make money off of it each way they can. So yeah, and I can say that in Israel there are a lot more people that are interested in getting into the field, that maybe did a course or a boot camp and are now looking for their first position. Then you have first and like entry level positions for data scientists and machine learning researchers, and just something to consider before you take the plunge.
Got it. Thank you. Good to know it's not like that only in Russia. Thank you. We have a question from Jane. What are limitations when using machine learning, and which problems can it solve?
That is it's a big question. What are the limitations? There are quite a few. Maybe the bigger one is that you need to make sure that you have enough data and that the data is good. That the data is a good representation of what you were trying to find, and it's a bigger problem than it might seem. We're talking here. We always talk in general in lectures. We talk about problems where we already have the data, because then that's where it gets to be data science. But a lot of times you don't